Today we're going to learn how to solve simple one-step equations. I want you to take these notes, copy them onto your note sheets. Here are the 3 steps, 3 main rules for solving equations. Step 1, isolate the variable. This means get the variable by itself on one side of the equation. Step 2, always use inverse or opposite operations to remove the number with the variable to the other side of the equation. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division, and inverse of division is multiplication. These are inverse or opposite operations. We always use opposite operation to remove the number with the variable to the other side. Step 3 is what I like to call the golden rule of algebra. This says to do unto one side what you do to the other. This means whatever you do to one side of the equation, you do to the other. If I'm going to add 5 to one side of the equation, I have to add 5 to the other side also. An equation is like a balanced scale. If I'm going to take 2 away from one side, then I better take 2 away from the other side in order for it to stay balanced. Otherwise, I'll have an unbalanced equation. Make sure you copy these notes. Pause the video if you need to. Now I'll show you an example of how to solve a one-step equation algebraically. I want you to show all your work exactly how I show you. Here's the first example. X minus 15 equals negative 76. So the first step is kind of a thinking step. It's asking yourself, okay, what do I do to get x on its own? I want to isolate x and get it on its own on the one side of the equation. When I say side, I'm talking about sides of the equal sign here. So that means I have to remove the 15, which brings me to step number 2. I'm going to use opposite operations to remove the number with the variable. So here I have subtracting 15, so I'm going to do the opposite and add 15. Because it's kind of like a negative 15 and a positive 15, they cancel each other out. I show the canceling with a slash, which brings me to rule number 3. Whatever I do to one side of the equation, I must do to the other. And here's where the solving comes in. Since I've canceled the 15 from here, x is now alone. So draw a big line to show you simplifying step. X is now alone, and it equals, here comes the actual solving part. Now I'm going to solve. I'm going to add negative 76 plus 15. Well, I know the rules of integers say that if I have a negative and a positive, I really don't add them. I find a difference. So I'm going to subtract those, and that gives me 61. Remember to keep the sign of the bigger number. Since I have more negatives than positives, my answer is going to be negative 61. So I am picky about the way I want you to show your work. I want you to show it exactly like this. Showing the inverse operation, doing the same thing to both sides, drawing a line to show the simplifying or solving process. I'm going to show you one other example. Down here, this example number 4. Negative 44 equals f minus 6. Make sure you're writing these examples on your note sheet. In this example, I want to get f alone. This time, f is on the other side of the equation. I want to get f alone, so I want to remove the 6. Remember, rule number 2 says that if I have addition, I do subtraction. I use opposite operations. In this case, I have subtraction, so I'm going to add 6. And that will remove the 6 from this side. F will be alone. Whatever I do to one side, I must do to the other. So if I'm going to add 6 to this side, I must also add 6 to this side of the equation. Now I show my simplifying. F is now alone. F, I bring down my equal sign. And remember, if I have a negative and a positive, I I'm really going to subtract those. It might help you to write the problem horizontally, because that's how we learn to solve those. And then you can see, okay, I have to subtract. I need to find a difference between 44 and 6. And that gives me 38. Again, the bigger number is negative, so I'm going to keep that sign. And my solution is f equals negative 38. If it bothers you to read it like that, you can certainly put the variable on the left and the solution on the right. F equals negative 38. Now I'd like you to pause the video and try numbers 1, 2, and 3. Try to show all your work algebraically exactly the way I just showed you. Unpause the video when you're finished and we'll go over your answers. Let's look at your solutions to numbers 1, 2, and 3. In number 1, we have x plus 12 equals 31. So in this example, I'm going to subtract 12 from both sides. That cancels out the 12 with the variable. X will now be alone. And now I'm going to have to subtract right here. 31 minus 12 gives me 19. How'd you do? Get that one right? Let's check number 2. Number 2 is 24 plus c equals negative 9. In this example, I'm going to remove 24 from the side with the c, and c will be alone. 24 minus 24 will give me 0. That's what I want. If I do minus 24 from this side, I must minus 24 from this side. And then I have c equals, this is a tricky one. Did you remember to write this horizontally? This says negative 9 minus 24, which is really not a subtraction problem, because when we rewrite it as an addition problem, it's negative 9 plus negative 24. This is really an addition problem. You need to add 24 to 9, and that will give me 33. Negative 33. How'd you do on that one? Let's check the last one, number 3. D minus 19 equals 20. Okay, here we have an example of subtraction. So I'm going to do addition, the inverse or opposite operation. Whatever I do to one side, I'm going to do to the other. I'm going to show my canceling. Negative 19 and positive 19, that makes 0. That's what I want, because I want D to be alone. D is now alone. It is now isolated. I'm now solving for D. And 20 plus 19 is 39. How'd you do? A good student will always go back and check their work. Checking your work algebraically simply means plugging in the number you got as a solution back into the original problem. I'll show you a quick check on this example. So I got 39. I'm going to plug 39 in for D here and see if it's really true. 39 minus 19 should equal 20 if I've done this problem correctly. And when I do the subtraction, 39 minus 19 does indeed equal 20. So I have solved it correctly. My check works. Okay, make sure you bring all your notes to class tomorrow and we'll practice solving equations together.